All right, get started in about a minute. All right, here we go. Any questions on the homework? All right, no questions. Check your work. 1 through 16 all. I'm gonna do this quickly. Number 1 is 26. Number 2 is 13. Number 3 is 9.43. Number 4 is 15.81. Number 5 is 11.31. Number 6 is 17.89. Number 7 is 20. Number 8 is 12.96. Number 9 is 39.55. Number 10 is 6.24. Number 11 is yes. Number 12 is no. 13 is yes. 14 is no. It's like a pattern here. 15 is yes. And 16 is no. Yeah, there was a pattern there. And that was it. Make sure you don't get lazy. Make sure you're turning these in on Teams. Here is our calendar. Remember, on Monday, you will be taking the PSAT test. They're going to take your temperature to make sure everyone's healthy. We're going to have very separated rooms and very separated desk in the rooms when you take the test. Make sure you got your mask and make sure you have your graphing calculator. You must have your graph. Make sure you have fresh batteries. It's charged if you have one that needs to be charged. You'll take that on Tuesday. Then we'll be back to e-learning. And I didn't update I did update it yesterday. That chapter 11 test is going to be on that next Friday. All right, my computer is doing some weird stuff here. Did this yesterday as well too. Strange. And the only way I found to fix it was just to wait a second and it would fix itself. All right, there we go. All right, here is tonight's homework. 2 through 26 evens. All right, today's class and probably some more that we do in this chapter are a perfect example of why probably wait till I post the video. If you got this, you got this. But if you don't, if you're a little wary of the material, play the video. Like, look at the problem that you're doing for homework. Skip through the video until I'm doing one just like it, and then just follow the steps. That will help you immensely in getting the homework done for the ones that give you problems. Remember, you can always send me a chat. Right? Sometimes I can't reply immediately, but I will certainly reply as quickly as possible, and at least up to 8 o'clock each night, and then I shut down. Okay, we're going to jump into this. This is big boy, big girl math for sure. It is on the scale of easy to hard. Once you understand what's going on, this is very easy. However, it does mean that you understood the previous material in simplifying radicals. Now, many of you probably aren't going to agree after you see what we're going to do. You might say it's complicated. There are 3 rules that you have to follow, but you're going to be doing these rules so often next year in geometry that, by a month into it, as soon as we get to square roots in geometry, you're going to be old hats at this, right? But this is your first look at this material. So I would say easy, hard day. It's actually pretty easy, but you can, because it's new and there's some silly rules involved, and they are silly. It can become a bit more challenging. Try not to get lost. If you're live here, make sure you ask me questions. All right, this needs to go in your notes. Okay, we're just going to jump right into it. to multiply two terms that have radicals in them. In other words, I've got two things I'm multiplying, right? Two numbers. One has a coefficient of A, one has a coefficient of C, and then I have two separated square root symbols. One has a B and one has a D. Remember I said easy, hard? Well, when you look at it, this looks like it's going to be hard, but it turns out it's easy. It turns out that all you do is multiply the outside with the outside and the inside with the inside. Literally, that's all you do. You take A and C and you multiply them together, the things in blue. You multiply the things in blue together. Then you take the things in red and you multiply them together. Then the things in red stay inside the square root symbol. The things in blue stay on the outside. That's what it turns into. And if that was all this was about, this would be a really easy day. But it gets slightly more complicated because we have to think about on the other things that we've learned this year, dealing with square roots. So what can be on the inside of the square root symbol could be a perfect square. It could be a non-perfect square. Sometimes non-perfect squares can be simplified. For instance, 72 can be written as 36 times 2, and you can take the square root of 36. You're going to see that today, right? But if you were good with what we learned already in the chapter, you'll be good with this because this is pretty simple. All right, so this is how you simplify radical expressions involving multiplication. Radical expression means there's going to be a square root symbol. Expression means there's going to be more than two things to do, or two or more things to do. All right, sounds simple, and it is simple. Sometimes it can take a few steps because what's underneath the square root symbol won't be a perfect square. It'll be an imperfect square, and you got to simplify it. Let's do one together. Here we go. 3 root 2 times 4 root 18. Well, the rule said outside with outside, inside with inside. So let's do outside with outside. 3 times 4 is 12. 2 times 18 is 36. So all I'm doing is multiplying the outside numbers, the ones in blue, put a big long square root symbol, and multiply the inside numbers together. Do you see what I did there? All right. Now we see if we, and you can't, sometimes you might not be able to, but a lot of times you will be able to simplify the square root symbol. What's underneath the square root symbol, we call the radical symbol, is 36. And that's a perfect square. The square root of 36 is 6. So this turns into 12 times the square root of 36, and the square root of 36 is 6. So this is 12 times 6, right? Remember, here's the explanation. Remember, square root gets rid of squaring. 6 squared is 36. No, you don't need to write this, what I'm writing right here. I'm just showing you why it works. The square root of 36 is 6. Therefore, that's 12 times 6, which is 72. So just so you don't get lost, that step that I wrote there of the 6 squared, that was just to show you that it's a perfect square and that square roots get rid of squaring. All right, we're going to do a bunch of these. You got to stop me if you're lost. All right. The rule says when you're multiplying radical expressions, well, you multiply outsides with outsides, inside with insides. Okay, so let's see. Sorry, I was sneezing. Well, some might say that the square root of 7 doesn't have a coefficient. Well, it does. It's 1. 1 times the square root of 7 is square root of 7. So that's where this 1 came from, 2 times 1. That's pretty simple. 5 times 7 is 35. And now we have to ask ourselves, can square root of 35 be simplified? Is there any perfect square that goes into 35? Let's see. 4 doesn't, 9 doesn't, 16 doesn't, 25. Okay, we're done. That one's simplified. All right. Haley, we feeling confident? Piper, how about you?
Yeah, I'm feeling okay.
All right. Haley says she's got it. Okay. So that's what's called the exact answer, right? It's 2 root 35. Now, tonight for homework, they may or may not ask you to write both the exact and the approximate answer. So the approximate answer is, well, you take your calculator and you multiply 2 times the square root of 35. So if you take your calculator and you multiply 2 times the square root of 35, square root of 35 is not a perfect square, so you don't get an exact answer. You get a big, long decimal answer. It goes on forever, never stops, because square root of 35 is irrational. So they may say, give me an approximate answer to the nearest tenth. Well, they're just asking you to take your calculator and do 2 times the square root of 35. All right, so you may see both of those for homework. They may say, give me the exact answer, and they say ask for the approximate answer. If they ask for an approximate answer, they're saying calculate. And I think they usually put a calculator symbol next to the problems where they want you to do that. All right, so let's do these two together. These are two separate problems. On the left side, we have 2 root 10 times 3 root 20. So following the rule, outsides with outsides, insides with insides. Well, that would be 2 times 3 and 10 times 20. All right, we can do that. 2 times 3 is 6. Let's see, 10 times 20 is 200. Now, hopefully you're getting really good at the simplifying process. And what we're asking you to do is now to look at 200 and figure out the perfect squares that go into 200. Now, obviously 4 goes into 200, but remember, we would like the largest one. So let's see, we got 4, 9, 16, 25, 36, 49, 64, 81, and ding, 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 100. Right? It turns out that 100 goes into 200 twice. So if you have chosen 4 times 50, well, then you'd have to do it a second time with 2 times 25. But if instead you realize that, well, 100 goes into 200, and the square root of 100 is 10. Remember, the square root of 100 is 10. Square root of 100 is 10. So therefore, that would be 10 times 6, and 10 times 6 is 60. All right, I'm pausing there for questions. Pausing there for questions. Like I said, we're doing big boy, big girl algebra right here. It is all predicated on the fact that you understand how to simplify square roots. If that's the part that's still giving you problems, then the only way you get better at it is practice. I would absolutely positively, just like I have right here, I would absolutely positively have these perfect squares in front of your face, right? Go all the way up to 256, right? Have those in front of your face so that you can think about these numbers, so that when you're given the square root of 200, you don't draw a blank. All right, the second one here, well, we got 3 numbers multiplied each other. Well, the rule doesn't change. Outsides with outside, inside with insides. So let's see, on the outside, well, there's a 1, there's a 1, there's a 1, and well, that's not very fun. 1 times 1 times 1 is still 1. But on the inside, 3 times 3 is 9, times 4 is 36. 3 times 3, remember, I didn't ignore the outside, but the outside is just 1. 1 times 1 times 1 is still 1. 3 times 3 is 9. Times 4 is 36. And hopefully you understand that the answer is 6. All right, big pause here. Piper, still we okay?
Yeah, we're good.
Riley?
I'm good.
Yeah, now this is for Riley and for the other 3 girls that are taking geometry. I mean, this would be the part from Algebra 1 that when you walk into the geometry classroom, you're supposed to already know how to do. So when you girls were struggling with some of this stuff, well, some of it's simply because you hadn't been taught that part. But you can do geometry, most of the book of geometry without this, but this will explain some of that stuff you probably have seen before. Okay,
Excuse me.
yes.
So for the last one, when it was like 60 square root 2,
Yep.
what determines whether you solve or not?
What determines what?
Whether you solve it or not. Because
There's
for
no
this one,
solving, there's
there's
just
a-
reducing. So once you get it down to, okay, you've multiplied the outsides with the outside, insides with the inside. So you got this right here. What determines whether or not it can be simplified further is that if there's any perfect squares in 200. For instance, if it was 201, there are no perfect squares in 201. You're done. So if it had been 201, it would be 6 root 201. But because inside of 200 is 100, well, we can simplify it further. So your real question is, well, how do I know when to stop? And the answer is, well, you continue at it until there are no more perfect squares. And you got to trust me when I say the more of these you do, the more confident you will get that, okay, I know what to do here. For me, whenever I'm doing these, I'm always thinking about 4, 25. Sometimes I'm thinking about multiples of 9. The more common ones, 36, 72, those are some common ones as well. So, I mean, it is more art than it is science, being able to simplify these things. And it is the challenge. For instance, if I write 2040, hopefully you don't have one of those tonight for homework. I don't know what goes into 2040 except for 4. So maybe I start with 4 and just do it multiple times. But that is a big challenge here of knowing, how do I know when to stop? All right, let's do some more. Left one here, outsides with outsides, insides with insides. Well, that's pretty easy. 5 times 2, and many of you would probably skip this step at this point. Now that you understand how it works, you might just do that part in your head. 5 times 2 is 10, 3 times 3 is 9. So many of you might, skip from here straight to there, and that's fine. Okay. Others of you might want to write this step just so that you can look at the numbers that you're multiplying. I will leave that entirely up to you. All right, so Haley, your question was, well, how do I know I'm done? So are you done? Is there a perfect square in 9? Haley? Oh, that was Anna's question. Sorry. Anna. So is there a perfect square in 9?
Yes.
Why are you doing this to me, computer? Anna,
Yes, there is.
what is that number?
3.
You got it. So the square root of 9 is 3. So therefore that would be 3 times 10, which is 30. Okay, that wasn't too bad. Second one, outsides with outsides, insides with insides. Well, there's nothing on the outside. I guess 1. 1 times 1 is 1. So not much going on with the outside. 11 times 44. Now this is the better question. Should I multiply 11 times 44, or should I leave that as 11 times 44 and break each one of those down? So there's no hard, fast rule. You're going to see me doing this one slightly differently. And the reason why is because if I multiply 11 times 44, I get this big honking number, and then I have to simplify that. If instead I take each of these individually, notice I was in the previous one there to the left, I'm multiplying 3 times 3. There's no perfect squares in 3, but there is a perfect square in 44, 4 times 11. So to make your life easier from now on, before you multiply the 2 insides together, see if you can already simplify one. It'll just make your life easier. Square root of 4 is 2. So that's what do you see what I did there? I factored 44 first. I shouldn't say factor. I simplified the square root of 44 first before I'm going to do the multiplication. It's not wrong to multiply 11 times 44. You can do that, but watch how much easier this is, right? It's easier to see that 4 goes into 44 than, I don't know, whatever 11 times 44 is, big honking number. Now look what it turned into. It turned into, well, basically the same type of problem. Outsides with outsides, insides with inside. So I know that, well, the outside of the square root of 11 is a 1. The outside of the second square root of 11 is a 2. 11 times 11 is 121. And well, I know what the square root of 121 is. It's 11. So that one turns into 11 times 2, which is 22. Hey, there was a lot going on there. Make sure you ask a question if you didn't understand what I did there. I could have multiplied 11 times 44. I chose not to. Notice over here, the reason why I multiplied 3 times 3, because there's no perfect squares in 3 and 3. There is a perfect square in 44, 4 times 11. So I chose to turn, I'm going to erase everything here. I chose to turn the square root of 44 into 2 root 11 first. One, it makes my life a little bit easier. It's like you're multiplying fractions together. You have a choice of multiplying straight across or cross reduce. We find out that cross reducing makes our life easier. It's the same basic idea here. You're just not multiplying fractions. You're multiplying radicals together, square roots. Okay, with that out of the way, that's actually the easy part. The second part is it's the 3 silly rules part. All right, division brings up some silly rules. The silly rules are made primarily because it will make higher level math easier. In the Algebra 1 level, you're going to look at these 3 rules and say, and for those of you in geometry, you've already seen these, you're going to say these are silly rules. But it turns out for higher level math, it does make your life easier. It just takes you to get to Algebra 2 before you finally figure out that, oh, that stuff that we learned in Algebra 1 does make my life easier. You're not going to see it in even geometry. You're just going to be these 3 silly rules that you follow when you have square roots and you're dividing, and you're not going to realize how useful it is until we get to Algebra 2 and pre-calculus and calculus. All right. So these are the 3 rules that deal with division and square root symbols. There's just 3 of them. The first one is, and we've already been doing this, by the way, is that you can have no perfect squares underneath the square root symbols. By the way, that's what we've been doing. Anytime we have a square root symbol, we get rid of any perfect square inside. It's the second rule that's a new one. It turns out that we are not allowed, we can have them to start with, but we will never leave an answer that has a fraction inside of the square root symbol. So it's not that you can't have a fraction, it's just that we don't leave any answer with a fraction inside. By the way, you've seen that as well too this year. The third one is the one that's brand new, brand spanking new. And it turns out that we will never have an answer that has a square root symbol in the denominator. Now, we're going to do each one of these rules one at a time, each one of these rules. All right, the first one, no perfect squares underneath the square root symbol. Okay, you just did that, right? If the answer is the square root of 44, we say, nope, you're not done, because you can't have any perfect squares there. So how do you deal with this? Well, you look at box 1, you figure out what perfect squares go into 44. 4 does. Square root of 4 is 2, so it's 2 root 11. We've already done multiple days of this. So you already know the first silly rule, right? The second silly rule, which is no fractions in the square root symbol, you've seen this before as well too. So if you have the square root of 3 over the square root of 7, we got to get rid of that fraction, right? The last one is the one that's brand new. Notice the difference between 2 and 3. 2 says that you can't have a fraction inside. 3 says you just can't have a square root symbol if you have a fraction in the denominator. So for the rest of the class, we're going to deal with 2 and 3. We already know how to deal with 1, right? You've been doing it all the time. All right, so we're going to be dealing with 2 and 3, 2 and 3. All right, so here is 2, right? Look, we got a square root symbol, we got fractions. Well, basically the answer can't have a square root and fractions. You got to get rid of those fractions. So how do you do it? Well, we go back to what we did already at the first part of the class. I have a square root times a square root. We multiply outsides with outsides, inside with inside. Well, on the outside, there's a 1. So 1 times 1 is 1. Nothing much going on there. So the insides now we multiply together. So all the rules of fractions apply. The rules for adding, subtracting, multiplying, dividing. We're multiplying. When you're multiplying, you can cross reduce. Look, there's a bunch here that we can cross reduce. Let's see. The 3 goes into 3 once. The 3 goes into 27 9 times. How about the 7 and the 14? 7 goes into 7 once, 7 goes into 14 twice. Multiply straight across. 1 times 2 is 2. 1 times 9 is 9. So I get that. Now, this was the first section of the chapter. We said that if you have a square root and a fraction, the way you handle this is you take the square root of the top over the square root of the bottom. See what I did there? It was the square root of 2 over 9. I just break it up into the square root of 2 over the square root of 9 and treat each one separately. Is the square root of 2 fully simplified? Yeah, it is. Right? There's nothing more I can do with it. On the bottom, I have the square root of 9. Well, I know what the square root of 9 is. Square root of 9 is 3. And I get that ugly thing. Now, we have to remember our 3 rules to see if we violated one. Are there any perfect squares underneath the square root symbol? No, there's just a 2. Are there any fractions inside? This is the hardest one to get used to. What they're saying is compare this one with the final answer. Notice this one has a fraction underneath the square root symbol. The answer here, oh, it's got a square root symbol, it's got a fraction, but the fraction isn't inside the square root symbol. The only thing inside the square root symbol is a 2. 2 is not a fraction, 2 is just 2. So we're okay with rule number 2 and rule number 1. Rule number 3 says no square root symbols in the denominator. We're good with that one. So check, check, check. We're good. We're good. First time we did that one. We better do a different one. All right, let's do another one. Ooh, ugly, right? Are you allowed to ever multiply with mixed numbers? The answer is no. So outsides with outsides, that would be 1 times 1. Inside with inside, we're trying to multiply with mixed numbers. Can't do that. You can only multiply with improper fractions or proper fractions. So I'm going to change both of these to an improper fraction. 7 times 3, 21, plus 3, 24 over 7. 3 times 2, 6, plus 1, 7 over 3. See what I did there? Now we can multiply insides with insides. Supposed to stop me if you're lost. Cross reduce. Ooh, 7s go away. What goes into 24 and 3? 3. 3 goes into 3 once. 3 goes into 24 8 times. The 7s cancel. Multiply straight across. 8 times 1 is 8. 1 times 1 is 1. When you have a square root and a fraction inside, you break it up into square root of the top over square root of the bottom. All right, there's more to do here on this one. So on the top, notice inside of 8, there's a perfect square, that perfect square of 4. 4 times 2 is 8. On the bottom, well, the square root of 1 is 1. Well, that was easy. But on the top, the square root of 8 could be written as 4 times 2, right? Square root of 8 could be written as 4 times 2. And the square root of 4 is 2. So what happened to our fraction? Remember, anything over itself, or anything over 1, you can get rid of the 1. Square root of 8 divided by 1 is the square root of 8. So our final answer is the square root of 2. Once again, we got to see if we violate any one of the rules. Hey, any perfect squares underneath the radical? No, there's just a 2. Any fraction? There's no fractions left at all. So 2 and 3 are also good to go because there's no fraction to deal with. Am I always going to have to think about these 3 things? Unfortunately, yes. From this moment onward, in geometry, the kids are already doing it, right? In Algebra 2, yep. Pre-calculus, yep. Calculus, all the time. You got to follow these rules. So these are the rules analogous to, let's just say, simplifying a fraction, right? You're never allowed to leave a fraction. If it's not simplified, it's always the last step, reduce the fraction. This isn't called reduce the square root. It's called simplify the square root, or simplify the radical. All right, we're not going to stop until you guys cry. Nobody's crying yet. Here we go. Outside with outsides, insides with insides. The outside is just a 1. Tonight for homework, there'll be something on the outside. Don't panic. On the inside, does anything cross reduce? Oh yeah, 8 goes into 8 once, and 8 goes into 32, 4 times. Ooh, 11 and 20. Yeah, some math teachers making these problems, right? 11 goes in 11 once, 11 goes into 22. How many times is that going to happen where everything cross reduces? All right, so we're left with that fraction. You're supposed to stop me if you're lost. 1 times 2 is 2, 1 times 4 is 4. We got a fraction, so the fraction underneath a radical symbol is square root of the top over the square root of the bottom. Square root of 2, fully simplified. Square root of 4 is 2. All right, our rules. You've seen the square root of 2 so many times, you know that that's always good to go. I do have a fraction, but there's no fraction inside of the square root symbol. There's just a 2. If it was 2 over 3, we got a problem. We're going to handle that one next. But there isn't. We do have a denominator, but there's no square root symbol in the denominator. So check, check, check. We are good to go. If this sounds painful, it's because it is painful. All right. So we haven't done the last one, which is no square roots in the denominator. Let's see what that one looks like. All right. That is what is not allowed. You get your final answer and you get 2 over the square root of 5. You're going to get this plenty of times. In algebra and geometry, we get this all the time. We get a square root symbol in the denominator after we do some math. Then you have to take care of that. Here's how it's done. You are not allowed to have a square root in the denominator. So what do? You multiply top and bottom by 1. Multiplying any fraction by 1 changes nothing. So why would I multiply by 1? Well, we're going to multiply by a flavor of 1. Remember, anything over itself is 1. So I'm going to choose a special flavor of 1 over 1. The flavor I'm going to choose is this one. The thing that's giving me a problem, square root of 5, I'm going to write the square root of 5 over the square root of 5. The square root of 5 divided by the square root of 5 would cancel. It's a 1. So what am I really doing? I'm multiplying by 1. Oh, lunch bell. I'm hungry. So I'm going to multiply top it whenever you have the square root symbol in the bottom. This is called rationalizing the denominator. What we're going to do is we're going to multiply the top and the bottom by the thing I'm trying to get rid of, the square root of 5. So I'm going to multiply numerator and denominator by square root of 5 over the square root of 5. Multiply. 2 times the square root of 5 is 2 times the square root of 5. The square root of 5 times the square root of 5 is 25, square root of 25, and the square root of 25. Look what happened. Just by doing that, I got rid of the square root symbol in the denominator. I've got one in the numerator, but that's fine. Remember, the 3 rules are no fractions underneath the square root symbol. The only thing underneath the square root symbol is a 5. No perfect squares there either. So here's the deal that a lot of Algebra 1 students, myself included, had a big problem. I looked at what I started with, and I looked what I finished with, and I said to myself, that's nuts. I started with 2 over the square root of 5, and I wound up with this big, ugly 2 root 5 over 5, and I wasn't happy. Why? Because it didn't look simpler. It looked more complicated, and unfortunately, both you and I are correct. It does look more complicated. This is the only one of the 3 rules that kind of seems really silly. And my algebra teacher never told me, like, well, why am I doing this? Why am I making it more ugly? Why am I making it more complicated? Well, the real reason is because algebra 2, you're going to be adding, subtracting, multiplying, dividing these things. And this will give me a much easier method of creating a common denominator. Nobody wants to make a common denominator. If this was 2 over the square root of 5, plus 3/4, nobody wants to do that, get that common denominator. Instead, hey, the common denominator is now going to be a 5 and a 4, and that's a whole lot easier to deal with. My algebra teacher never told me that. They just said, all right, that's a silly question. Don't worry about it. But I'm sure you guys have that same question. Why am I doing this? All right. And unfortunately, we're not going to actually, I think in geometry, we might actually see the benefit of it once or twice, but not very often. Algebra 2, pre-calculus, oh yeah, you'll see the benefit of this. We better do some. All right, so let's do this one. All right, so we got the square root of 7 over the 7/8. We know how to handle this one. We take the square root of the top over the square root of the bottom, right? Square root of the top over the square root of the bottom. All right. Well, the top isn't going to give us any problem. There's no fraction in the top, but the bottom does. Well, first off, I got the square root of 8. So there is a perfect square inside of the square root of 8. And by the way, you're going to do this lots of times where you're going to see a square root of 8 and you're going to be comfortable. In fact, some of you are going to memorize the answer and you can already write the answer. We can write the square root of 8 is 4 times 2. Square root of 4 is 2. So I get that big honking mess right there. All right, well, let's see. Where is our problem? There are no longer any perfect squares. There's now no longer any perfect squares underneath the square root symbol. So check on that one. There is also no fractions underneath the square root symbol. It doesn't look like, I don't know, 7 over 5, right? I have a fraction underneath the square root symbol, but I don't now. I started with one. It's the last one we got to deal with. The last one says you can have no square root symbols in the denominator, and look, we do. This is what's going to give us a problem. We can't have the square root of 2, but it's an easy fix. All you do is multiply the numerator and the denominator by the thing that's giving you problems. What's giving me problems? The square root of 2. So I'm going to multiply the top and the bottom by the square root of 2. What am I really doing? I mean, that's 1. The square root of 2 divided by the square root of 2 is 1. It's a big honking 1. So I'm not really changing values. I am changing the form or what it looks like, but I'm not changing values here. Okay, now we just follow the rules that we followed before. Let's see, insides with insides, outsides with outsides. 7 times 2 is 14. 2 times 2 is 4. So once I do that math, right? That's a lot of math though, but once I get that, 7 times 2 is 14, 2 times 2 is 4. We look at the problem again. Are there any perfect squares in 14? 4, 9, 16, nope. But I can take the square root of 4. The square root of 4 is 2, and 2 times 2 is 4. Do you see what I did there? Once again, the problem I had was I looked at what we started with, I looked at what we finished with, and I said, I don't really feel like I've made it any simpler until I got to Algebra 2, and they said, okay, you start adding these things together. So for instance, add the square root of 7 over 8, add the square root of 7 over 8 with a quarter. I'm like, well, I don't know what that is, but check it out. Remember, square root of 7 over 8, we just literally turns into this, so I can add those together very easy. It's common denominators already. My math teacher, for some reason, never wanted to tell me that. Maybe it doesn't cause anybody problems, but it caused me problems. One more, maybe? One more. Okay, let's see what happens here. So we have 2 big ugly fractions multiplied together, and they're both underneath the square root symbol. Outsides with outsides, inside with inside. Okay. Anything cross reduce? Yeah, that 10 and the 2. So get rid of the 10 and turn it into a 5. Get rid of the 2, turn it into 1. Multiply straight across. Stop me if you're lost. 5 times 1 is 5. 13 times 1 is 13. Square root of the top over the square root of the bottom. You're like, well, why didn't I do that from the start? Well, because remember, we were multiplying. Okay. Square root of the top over the square root of the bottom. Any perfect squares inside of either one of them? Nope. For 5, nope. For 13. We got square root in the bottom. We got problem. So what do? You multiply top and bottom by the thing that's giving us the problem. The thing that's giving us the problem is that square root of 13. So that's what I'm going to multiply top and bottom by. Insides with insides, outsides with outsides. 5 times 13, 65. Hey, square root of 13 times square root of 13 is 13 squared. That's just 13. So I would argue if my math teacher had shown me more of these problems, I might agree that, okay, it made it a little bit easier. But that's how that one was done. You guys have been awfully quiet during class, except for the start. I'm a little bit worried that I've lost some of you. Is that true or false? Or we're like, okay, this isn't too bad.
It's not.
And what I said at the start of class, what I would recommend, I'll have this posted by, I don't know, 12:30 maybe. Yeah, by 12:30. So I'll have the class posted. So if you're doing your homework and you get stuck on something, pull up the video, fast forward until you find one that looks like one of the ones we did in homework and just see what my steps were and just emulate the steps that I take. All right. Here's another one. Hey, look, there's no multiplication going on here at all. But we got a problem because this violates the third one, no square roots in the denominator. So what do? Well, we multiply top and bottom by the square root of 35. Okay, 2 times 35, outsides with outside, inside with insides, 2 times 35. And well, we already know how the bottom, as soon as you see how this story ends, you kind of know what goes on. Square root of 35 times the square root of 35 would just be 35. It would be 35 squared, and the square root of 35 squared is 35. So the bottom turns into 35. The top turns into 5. Root 2 times 35 is 70. Ooh, 70. Once again, when you're stuck with these problems right here, you have to have a good handle of box number 1. Well, are there any perfect squares in 70? Well, I don't need to consider one. I'm showing you the answer, dang it. All right. 1, 4, 9, 16, 25. 25 goes into 75, but not 70. 36 goes into 72, not 70. 49, 60. No, none of those do. But maybe you didn't see it. I did show you the answer. Is that we can reduce that fraction. 5 goes into 35. What, 7 times? So final answer, you already saw it. Would be the square root of 70 over 7. So you might see a couple problems that look like that, where you get to the very end and you have a coefficient on the top and a number on the bottom that you can reduce further. And that, ladies and gentlemen, is the last example. I chose one from every part of the homework. However, the homework is, if anybody has their books open at 538, 2 through 26, somebody can yell out a number and we could do a couple of these together. We got time. Anybody want to do one of these together?
Number 20?
Let's do number 20 together. Number 20 together. All right, so number 20, it's these big, ugly mixed numbers. We have 2 2/5 times 1 2/3. The square root of 1 2/3. All right, now we know we can't, outside with outside, there's a 1 and a 1. That doesn't turn anything. So for the inside, we can't multiply with mixed numbers, so we're going to change it to improper fractions. 5 times 2 is 10, plus 2 is 12, so we get 12 over 5 for the first one. And on the second one, 3 times 1 is 3, plus 2 is 5, we get 5/3. And if a math teacher wrote this problem, there'll be a whole bunch of things that you can cross reduce. And since it's from a math book, a math teacher did. Look, the 5s cancel. Hey, 3 and 12. 3 goes into 3 and 3 goes into 12 4 times. Oh man, a math teacher wrote this one because look what happens. That whole thing literally turns into the square root of 4. And you're like, no, it's 4 over 1. Okay, I'll go with what you said. Turns into 4 over 1. Now, granted, 4 divided by 1 is 4. But following what you wanted me to do, the square root of 4 over the square root of 1, I'm making this way more complicated. We would have been done. Square root of 4 is 2. Square root of 1 is 1. 2 divided by 1 is still 2. However, at this step right here, I mean, really, it's just the square root of 4. There's number 20. Anybody else? We can do one more. I gave you what, through 26? Is that what I gave you? Yeah, 2 through 26. Nobody? Okay.
24?
24. Yes, I'm lonely and I want to do math. All right. 5 root 48. I keep looking at all these empty desks. It's lonely. I am in the building today. 5 root 48 over the square root of 39. So this is one of those ones that really requires you to have a good command of your perfect squares. A good command of your perfect squares. All right, let's see what we can do here. Any perfect squares in 48? Right, before we multiply by the square root of 39, I don't want to do that. Yeah, 16. So that could be written as 5 times 16 times 3. This is where having a good command can save you some time. If you thought that 4 does go into it, it would have been 2 steps. Any perfect squares in 39? Let's see, 4, nope. 9, nope. 16, nope. 25, nope. 30, okay, there's no perfect squares in the square root of 39. All right, so how about this one? Square root of 6, square root of 39, sorry. And the reason why I didn't want to multiply top and bottom by the square root of 39 right from the start is because that'd be a big honking number. So I'm going to reduce this one first. Square root of 16 is 4. 4 times 5 is 20. So we get 20 times the square root of 3. All right, that's way better than to multiply 48 times 39. Now we're eventually going to have to multiply by 39. We're good to go on the top. We're not good to go on the bottom. We need to get rid of that square root of 39 over the square root of 39. All right, so let's see. I can't avoid it. On the top, let's see. What are we going to get? 3 times 39. 3 times 9 is 27. Carrying my 2. 3 times 3 is 9 plus 2 is 117. So I get 20 over, I know how the bottom ends. The square root of 39 times the square root of 39 is 39. All right. So here is the only issue here is that 117. Suspiciously, I'm thinking there's got to be something going on there with 117. So I'm grabbing my calculator and I'm typing in 117. I'm just going to see if anything goes into it. It turns out that 9 goes into 117, right? Now, how are you going to know that? Is you just always have to be suspicious. You always have to be suspicious that some number goes into it. All right, so that's going to equal, let's see, 20 times, and it turns out that 9 times 13. Ooh, 13. That 13 kept popping up. And that's all over 39. So let's see. That's going to give me, pull out a 3. That's going to give me 60 over that. Square root of 9 is 3. 3 times 20 is 60. 60 times the square root of 13 over 39. And it feels like we should be done. But it turns out that 3 goes into both 60 and 13. 3 goes into 60 20 times. We're back to 20. It's like we are not making any progress, but we are. And 3 goes into 39 13 times. That was a lot of work there. That's why that's number 24. There you go. All right. Thanks for sticking with me through that whole class. Any questions on anything we did?
No.
All right. Obviously, the first, let's say 20 are pretty straightforward, and you get to 22, 4, and 6. They're a bit more challenging, but you guys should be able to do those. If you do have any questions, send it to me in chat. I'd be happy to help you out. Let's see. Tomorrow's Friday. We're going to be, yeah, I guess we have to do assembly schedule. I haven't heard whether or not, I haven't checked my email in a while. I don't know if she's actually going to have an assembly or not, but we'll stick to assembly schedule for tomorrow for class as well too. All right. As always, I'll